over. Alright?
Yes.
Alright, so we have sine, cos, tan. Alright, so what's our ratio for sine?
Opposite over hypotenuse.
Opposite over hypotenuse. What is our ratio for cos?
Adjacent over
Adjacent over hypotenuse.
Hypotenuse. Tan?
Opposite over adjacent.
Alright, what about, guys, what about the rest of our ratios? What about our cot? What is cot? 1 over tan.
Yes.
Because, guys, the way we remember this is that
It
cot
has a
has a T in it, tan has a T in it.
And then
Yes.
we, for the other ones it's complicated, but we remember the
Yeah.
opposite thingy.
So sec will be 1 over cos.
It has a C.
Cosec is 1 over sine. Alright, so these are the ratios you have to remember.
That one has an S.
Okay.
Did I ask you about the calculator or the periodic table?
Yes.
Oh, okay, sorry.
I said, who's gonna know? Alright, so if I have a diagram, looks like this, it's got a point, 6, 7. Alright? Has a point 6, 7, and this is R, and this is theta. Alright? I want you to calculate R. Determine sine theta plus cos theta. So, how do we get R? Alright, Pythagoras. Guys, how do we get R? We use Pythagoras.
Yes.
Alright, so our x value is equal to 6. Our y value, 7. Do you see that? Alright, so to get R,
That's here I go to.
alright, to get R, we say R squared is equal to 6 squared plus 7 squared. Alright, R squared is equal to 36 plus 49 gives me what? 85. So R squared is equal to 85. R is equal to root 85. Alternatively, yeah, you don't need a reason. Guys, quiet. You don't need a guys, quiet. Turn around. You don't need a reason unless they ask you with reasons. All right, for trigonometry.
Okay.
Okay. So guys, our answer here is root 85. So now we have our theta. So this will be our opposite. This will be our adjacent. That will be our hypotenuse. So I'm just going to make a note for myself on the side. Opposite is equal to 7. Adjacent is equal to 6. And hypotenuse is equal to root 85. Alright?
Yes.
From here, I say it wants me to calculate, determine sine theta plus cos theta. So sine theta would be my 7 over, please stop talking, root 85. Because that's my hypotenuse. Plus, alright, determine sine theta plus cos theta. Alright, plus 8 over root 85, 6.
Isn't it 6?
6 over root 85. I'll plug that into my calculator.
13 over root 85.
13 root 85 over 85. Otherwise, you can convert it to a decimal being 1,41. All right. So, do you guys understand how I did this?
Yes.
All right. What if I say calculate theta? This isn't in degrees. All right. Calculate theta. How do I calculate theta? Calculate theta.
You put say -1.
All right, so I'll say sine -1. All right, and then I have my sine, which is 7 over root 85. Plug that into my calculator. 49.4. All right, so theta equals 49,4 degrees. 49,4 degrees. Alright guys, so if I have a sine, stop talking, x. What does A stand for? If I'm looking at a graph, A sine x.
Gradient.
Amplitude.
Oh,
What?
Yeah. I'm looking at my sine graph, I have A sine x. A cos x and A tan x. Right? What does x stand for? The first two. Amplitude. Alright, the third one is not the amplitude.
These days we have to count graphs.
What does the A stand for? Alright, our amplitude. What does the Q stand for? Vertical shift, thank you. Q stands for vertical shift. Right. Stop talking. I will wait. Okay.
Why did you put +2?
Because the Q is our vertical shift.
Now we're getting no tan graphs.
No tan graphs. Alright, so now, if I say draw 2 sine x and 4 cos x plus 1 on the same sort of axes, draw it for me. Alright, so my first one is at 90. So at 90, the sine is 2. At 180, it'll be 0. Alright?
Madam, I have a question.
270.
Madam, I have a question.
Yes?
How much space when we're drawing this graph should we leave in between 90, 180?
As much as you want. Leave 1 centimeter, leave 5 centimeters. That's fine. Okay. Yeah. So our graph goes like that. You guys see it? Alright, I want to redraw it to make it look nicer.
Madam.
Yes.
Madam, what number is 270? -2. Hey! Bum! Wait, mate.
Okay, guys. So you can see our graph here. This is our 2 sine theta graph.
Yes.
2 sine x. Alright, so now I need to do my 4 cos x plus 1. So if I've got a cos graph, does it start? It starts up here at 4, but it's plus 1, so it'll start at 5. Okay, because normally a cos graph will look like this. Alright, that's what your cos graph looks like. But since it's 4, we know our amplitude is 4, so it starts up there. Right? Yes, guys, enough talking. Alright, so we start at 4, that's 4 plus 1, so we start at 5. Alright, so if we start at 5 at 90, it would be 0, so it will come down to minus 1. Sorry, it will come down to 1. Sorry, minus 3. 1. At 180 it will be minus 3. At 270 it will be 1. 360 it will be 5. So now, at 180 it is minus 3. Minus 3. Okay. So what I do, if I want to calculate what it is, I always use these 4 values when I'm calculating my sine, cos, and tan graphs. My 90, 180, 270, and 360. I plug it into my calculator. I say 4 cos 90, close brackets, plus 1. Gives me 1. That's how I know I need to plug in 1 for 90. And then I go 180. Alright, gives me minus 3. You see how I do that? Alright, so those are my 2 graphs. What is the, guys quiet please, what is the range of our sine graph? What is the range of our sine graph? So our sine graph, the range of sine graph, so range of 2 sine x. What's the range of 2 sine x? We say x is an element of
Negative 2 is to 2.
negative 2
Y.
to 2. Range, yeah, y. Yeah. Y is an element of negative 2 to 2. Because that's as far down as it goes, and that's as high as it goes. Now, what is my amplitude?
4.
Of my amplitude of 4 cos x plus 1. My amplitude is 4 because my A value is my amplitude. So my amplitude is 4. Okay, do you see the difference there? Bravo. Alright, do you see the difference between amplitude and range? The range of 4 cos would be 2 minus 3 minus 3 5.
Wait, where is it 4?
The domain is 0 to 360. So the range, what would the amplitude of 2 sine x be? 2. What would the range of 4 cos x plus 1 be?
Let's see.
5 and negative 3. So y is an element of negative 3 to 5. The next thing we're going to do is I've got 3
Is this trigonometry?
cos, yes, we're doing trigonometry. 4 theta plus 20 equals 2. Solve for theta. How do I solve for theta? Okay, so I want you guys to concentrate for this. I can see lots of them concentrating. I don't like doing it again. Alright, so first thing I do is I take my 3 over. So I've got cos 4 theta plus 20 is equal to 2 over 3. Okay? So that's the first step. So then I say cos minus 1 is equal to 2 over 3 is equal to 4 theta plus 20. Do you see how I've done that? First I take the stuff on the outside of the bracket, and then I take the cos and put what's inside the bracket over there, and swap those two around. Do you see that? Alright, so now my next step is I say cos minus 1, 2 over 3, which gives me 48,19. So 48,19 is equal to 4 theta plus 20.
20.
So take 20 over, I've got 28,19 is equal to 4 theta divided by 4. Alright, 7,05. So then theta would be 7,05 degrees. Do you guys see how I did that? It was a process of steps that I go through. My first step is to take over my 3. Alright, so my number in front of my trigonometric ratio. And then, alright, after I've taken the number in front of my trigonometric ratio over, then I do cos to the minus 1. And I swap what's in the bracket on this side, which is what's in the equal sign. I swap those two. Alright? From there, I work out what cos to the minus 1, 2 over 3 is. Alright, and I get 48,19. Then, I can only start working on this side. Then I say, I take the 20 over. When the 20 goes over, it becomes minus 20. Then I divide both sides by 4. Alright, so I have theta is equal to 7,05.
Yes.
Okay.
Degrees.
Yeah, degrees. So now it says without a calculator. Yeah, but we do use a calculator.
Doesn't matter.
Alright, without a calculator, sine 45 times cosec 30. Cosec 30 over tan 60 times cos 30. Alright. So, this is what I want you to calculate without a calculator. Alright, so what I do, my first step is I take my cosec and I convert it into something I can use. So, it'll be sine 45 times cosec, so that's 1 over sine 30 over tan 60 times cos 30. Now I plug each of these ratios into my calculator separately. Alright, so sine 45. Sine 45. Root 2 over 2. Alright, so I'm going to start on this side. I'm going to carry on over here. Alright, so you see how we're using a calculator for a not use a calculator question, but it's still fine. Alright, you'll still get full marks if you do it this way. So now what we do is we say sine 45 is root 2 over 2 times, guys, 1 over sine 30. So sine 30 is a half. So 1 over 0,5 over tan 60. Root 3. Alright, times cos 30. Root 3 over 2. Alright, so guys, do you see how I have used my calculator for this question, but I haven't just plugged the whole thing into my calculator. Alright, I've done each step. Alright, so first I converted my cosec to 1 over sine 30. And then I did this. Alright, so what's 1 over a half? It gives me 2. So I've got root 2 over 2 times 2 over root 3 times root 3 over 2. So now what you can do is you can plug the top into your calculator. Alright? So now we say root 2 over 2 times 2 gives me root 2. Alright, so now on the bottom we have root 3 times root 3 over 2. That gives us 3 over 2. Alright, so now you can plug this into your calculator. Root 2 over 3 over 2 gives me 2 root 2. 2 root 2 over 3. I plugged it into my calculator. That's how I did it.
How much marks is this?
This will probably be 4 marks. Okay. Alright.